Hi, I'm Mr.G. Welcome. Got a new build going on. We're gonna give you the start to finish on this build. We're gonna do an engine dyno. So I got some engines here, right? These are tiny little engines that usually go on inside of a like an RC airplane, like a remote control airplane. This, believe it or not, has a 1/4 horsepower. That's right, 1/4 horsepower. So 10 of those, well, so 4 of those would be like 1 horsepower. All right. They usually turn like a prop on an airplane, but we got a whole bunch of stuff in here, and we're gonna make our own engine dyno. So we've got electric motors here. Look at the size of this motor. That's a huge motor. And we got this one here, and we're gonna use some automotive equipment to make the dyno. So this will be the first time I'm ever doing this, so I needed some help, so I brought in my man Manny. All right, now this is his shop. Let me just give you a quick tour real quick, and I'm gonna introduce you to Manny. All right, so Manny's got automotive background, but he also builds manufacturing equipment. So if you ever needed something in a package, you ever get like a ketchup packet? You ever wonder who designs and builds those ketchup packets? He makes something like that, but what he does is he makes the machine that makes the products fast too, kicking out a lot. So if you're gonna do something like this, you need capability. So think about this, he's got the mother and the father of all machines. Here's the father, this is the milling machine, right? You've got an X and Y axis, and then a Z is on here. It's kind of like a really big drill press. And then you've got the lathe, the mother, okay? The lathe spins around and the tool stays put, and it cuts it almost like a baseball bat. You could cut a baseball bat here, okay? And over here, you could cut anything that's in 3 dimensions. You guys know about 3D printers. It's kind of like a 3D cutter, okay? But also all the support equipment, right? Chop saws, miter saws, band saws, horizontal band saws, all the parts and whatnot, right? He's even got a forklift, okay? Welding equipment, everything, right? This is a full shop. This is like a dream. This is like a dream shop, you know? Every guy or girl going into the STEM field, who engineers, people that are thinkers, you know, and problem solvers, they want to make a prototype. This is what they would do. They would build a shop like this. Let me introduce you to Manny real quick. Manny, say hi.
Hello.
Okay, Manny's got his little office here. He also has, you know, SolidWorks and access to the internet and whatnot, and he works on his plans here. I mean, he is a smith. He is a engineer, start to finish. Cool. The cool thing about Manny is he can go start to finish, from concept to reality to installation to maintenance and even training the workers. He's a full circle individual. That's rare. Not a lot of people can do that. And he's humble. And he's humble. And he's not going to say yes. So
yeah, this office, we just do the plan review and print stuff out that needs to be fabricated or assembled or whatever. Mm-hmm. All the design work happens in the comfortable office.
Right, right. So you have SolidWorks hooked up here?
Yeah. There's SolidWorks here and SolidWorks in the comfortable office, as I called it.
Okay.
And
nice.
I just use SolidWorks here to do plan review or make in-field changes while we're in the shop, but no major stuff.
Right. And then once you design it, you could either send it out or you could fabricate it right here.
Right. So my business model revolves mostly around farming out work. So I'll design the machine, I'll send it somewhere else to be manufactured, the individual parts, because I don't have CNC machine capability. You know, I don't have a full machine shop here.
Wait, CNC, just so people know, CNC is like automated control, almost like what you see with a 3D printer, where you have a design and then it automatically prints it. The difference is that we need something that cuts. So when you have something that cuts, it's a little more complicated because the tools can crash and whatnot. So you send out stuff like that?
Right, so CNC is computerized numerical control. I only have numerical control machines, so that's manually operated. It's numerical control because you either use a dial to control your axis position or your vector, or you use a digital readout. I have the luxury of having digital readouts, makes your life easy, makes it a little bit more precise, but the ultimate is CNC.
Let's just show them the digital readout right here.
Yeah.
So let's go over here.
So, old school numerical control, you have this dial here. This is your x-axis. So, to get a 0 position, you know, you'd spin this dial. Once you get to your 0 position, you set that to 0, lock it in place. Whoops. Do that again. You lock it in place. And now you know where you are based off of a 0 point, left, right. Do the same thing for the Y, which is front to back, and the X, which is up and down. But fortunately, with modern technology, we can put a little calculator on there with some scales, and this tells us our exact position X, Y, and Z. And we can do some fancy calculations to do bolt patterns, bolt centers, all kinds of crazy stuff on here.
Cool. So now if I move this, those numbers are going to move?
Yeah.
Okay. Is it locked?
Here, I'll move it for you.
Okay.
So we make sure the table's unlocked and we go ahead and move our X. You can see that's going that way.
Just so you guys see what's happening here, the whole table's moving. Almost like a conveyor belt. But imagine you can put your object here and you can conveyor belt it down in a fixed position that you can calculate, and this is your cutter.
Yeah. And we have the same luxury on the lathe. We also have a digital readout, and these machines are not very fancy, but for what I use them for, they're great. All I have to use them for is to fabricate minimal parts for assemblies that I put together, or make modifications to 1 or 2 parts. That's pretty much it.
Nice. And like I said, this is a shop. Is this your dream shop, or is there more?
So this is my dream shop for personal use.
Okay.
I just happen to be able to use this for my business,
Right.
as well, because my business has nothing to do with cars, and as you can see, I maintain my own vehicles in here. I've got 2 of my old cars in here that I beat up, and but yeah, when I'm building a machine in here, this place is empty, no cars.
Gotcha.
Yeah.
What would you add to this in the future?
So I think the next machine on my list is going to be a water jet.
Oh, okay. And a water jet, I saw something over here, maybe as an example of these little triangles.
Yeah, this was all cut on a water jet, exactly.
So this would be like an example. You're able to precisely cut with a clean edge something like, I'm putting my finger on this. This, believe it or not, was cut with water. And it has a really sharp edge, not enough to cut you, but this is precise.
Yeah, compared to milling this, the edge that's left behind is actually, I would consider that a broken edge.
Okay. So it's softer, right?
Yeah, it's much softer. You can still feel it sharp, but you'd have to put a great deal of pressure on this and drag your finger in order to produce a cut.
Right.
So it's workable as it comes off the machine. Handleable, I should say.
Yeah. And
But,
people should know some of these triangles. I'm guessing this is for a gusset.
Yeah.
Of some kind.
This is a gusset.
For strengthening. So if you look back on my gusset video, you'll see that we use gussets to triangulate stuff to make something that would be like a big L into something stronger.
Yeah,
because
for example,
yeah,
it would go in this corner to reinforce the corner.
right there.
That's not really where the part goes, but this is a good example.
That's a perfect example.
This is an example of a gusset.
Right. And simple explanation of a gusset I always do is your feet, when you're playing basketball or football or something, you're going to go like this, and that creates a triangle. I don't know if you can see that, but the triangle gives you stability. Is that in there? Okay. So like this, you could fall over, but like this, you have a triangle and that gives you much more stable, and you could do that with machines as well.
Right. And another thing about the water jet, it uses high pressure water and sand combined to make this cut.
Nice.
And unlike a plasma cutter, it's not material dependent. You don't have to have a conductive, electrically conductive material to produce a cut. So any material that you can think of, put in that machine.
So you could do even plastic.
Plastic. Technically, you could do wood, but that's not really the right application.
Oh, it's very versatile.
Yeah.
And also, the water jet is kind of made popular in like popular culture from Orange County Choppers shows the water jet a lot.
Yeah. They
cut a lot of parts on there, and you can get pretty detailed with those cuts. But anyway, so you're adding to your capability and speed and repetition, right?
Right.
Yeah.
So I'd like to add more machinery that increases my capabilities for building frames. Any of the components, machine components that require welding, the overall frame or individual trusses and stuff that need to be welded together, I'll fabricate all of that here from scratch. I won't farm that out. So I've got pretty good welding capability in-house.
So he's got a welder right here, and it's a similar setup that you've seen me use. This is a TIG welder, and he's got his argon gas, and it's almost like all the same capability that you've seen at the high school or at the college where I work, except he's got it in his personal shop. So if in the future, if someone was thinking about, wow, what's it like to have this at your house? Well, you could make anything you want, you know, which is a cool thing. It really comes down to your creativity, I think, right? Would you agree? So I think my initial impression of a welder when I was younger was like this big burly guy that works on buildings. But that's just part of the picture. You know, really it's about creativity and putting materials together. So as an example, Manny designed this table, and this table has been welded together. So even on the, it's very simple to show you that there's welds throughout, you see, and welding is just putting material together. So it's pretty amazing. So it's like a creative outlet, you know, you can just think of something and make it.
Right. Yeah, and this table, as designed, this table had a lot more complexity to it, but like life, like all things in life, you know, you run out of time, you gotta get work done, so he's put the fun stuff aside for a minute.
But the cool thing about this table is it's very heavy duty, but yet what Manny wanted was that it rolls. So you see, you can drop these down, and then they roll. Is that right?
Well, the way this table works to move it around is these wheels are stationary as far as their z-axis height.
Oh, I see.
So whenever you get it to where you want it, you come in here, and this has a 1/2-inch square drive, so you can stick a ratchet in there.
Wait. See, this is trick.
Okay, let me get the thing.
This is where it gets creative. That table looks like you'd have to jack it up or something, but he built in the jacks. You can't buy this table, right?
No, you can't.
No, this is his idea. And this would be a perfect example of what Manny would do.
So once you get this table where you want it, because the top of this table is really meant to be a fixturing table.
Okay, like something to hold something.
Yeah, it's flat enough to build a chassis on it, or assemble a group of parts that really need to be pretty flat.
Right.
It's flat enough to get that job done. So if you want to use a level on this table when you're assembling things, and you, wherever you got it, you want it a dead nuts level, you would come here and you jack these corners up one at a time until the table is anchored and the whole thing is level.
Right. Interesting.
That's pretty simple.
And then drop it back down, right?
Pick the leg back up, and that gets the table moving.
Oh, I see. So now we're on the wheel, right?
Right. Now we can.
Yeah, I could see it. We're on the wheel now. And can you drop it back down? Oh, there it goes. Awesome. So now the wheel is free.
Right.
which you can totally see me doing right here. Very cool. So this is the kind of stuff where you can't buy it, you could create it on your own. It's your thought, you know, you spent time, I remember you spent time on SolidWorks thinking about this table for a couple years already, right? And then you finally got around to it.
Yeah, it was in my head for a long time, and I finally got it in SolidWorks. And
yeah.
Originally, I wanted it to be a lot more complex. Like I wanted the lifting part of it in the corners to be hydraulic.
Oh, okay, yeah.
And there was like a lot of crazy stuff that I kind of deleted because it cost too much money. So
right.
It's like gotta go simple.
But functionally, it works.
Functionally, it works. Yeah.
So this is why I wanted to introduce you to Manny. He's a fantastic person to know and to understand the capabilities that he has. But also, that's also why I partnered up with him on this build here. We're going to do an engine dyno. I've never built an engine dyno, and I would like to learn more about that. So we're starting really small. I already showed them some of the engines, and we're doing really small just for just so you understand what's going on here. There's a pencil, and you know, so I come out to Manny's shop and we get to work on something like this. Now here's the trick to the whole thing. I haven't gone outside yet.
Oh.
They don't know where we are.
Okay.
Okay. So I'm gonna walk outside and just show you where we are, okay? Because you guys know I'm from New Jersey. Actually, Manny's originally from New Jersey too. Let's take a look outside. All right, here's the door. Whoa. We are in Nevada. And there's a little rabbit over there. And if you look around, it is absolutely beautiful. There is, that's just the air conditioner going on. These mountains, are those 11,000 feet?
I think they're 10.
10? This is like 10,000 feet elevation right here. This is flat. And basically, we're in the country. If you look out here, there's nothing but tumbleweed out here. And it's wide open. We got some dogs barking. And what's really cool is they filmed Mars attacks. Not far, just a couple of blocks from here. And basically, when you get to the end of this street, there's no more street. And those mountains, believe it or not, they're in California. So we're on the border of Nevada and California. And it's just a beautiful place to be. It's very quiet out here. Yeah, there's a dog and an air conditioner, but that's it. Lots of traffic, right? What's the traffic report today? Would that be no cars?
Yeah, 0. Well, if you count us, that's 1.
Okay, so look, there's a huge traffic jam at the corner here. And anyway, I just wanted to show you, you know, a situation where, you know, you could use your creativity and get some land and build a shop. All right, well, this is Manny's workshop, and we're gonna go build an engine dyno. All right, so stay tuned for part 2 when we actually have an engine running. Okay, thanks for tuning in. See you later.